Okay, Liliana, it looks like I got a couple of questions here. We got the leprechaun putting pennies under the pillow. This is very similar to the rice question you did in homework. So I'm going to pull up Excel here. And let me make them bigger. Although I think I'll need more space. Okay, so we have a day. We have a number of pennies, and we have value, or total value. Total value. Okay, so what we're going to do is we're going to play with some numbers for a second. So I'm just going to fill in some days. Alright, so on the first day, she got a penny. On the second day, she got 2 pennies. On the third day, she got 4 pennies, because we're doubling it each time. And so what I'm going to do is I'm going to tell Excel, why don't you take this and double the day before? And so the nice part is I can just drag that down. Okay. Now those dollar signs simply means the number's getting too big for the cell, so I need to make it bigger. Okay. All right. Total value would be, well, if there's, I need to multiply the sum of numbers by the amount, well, worth a penny. Let's do this. I'm going to move this column. We'll talk about total value in a second. Let's talk about sum so far. Sum meaning how many pennies have we gotten so far. Okay. So that's going to be, in this case, it's going to be 1. This will be the sum of those 2. This will be the sum of those 3. I'm just curious if I can drag it down, if it's going to do anything for me. Let's see, is that right? If I take G4 to G6, oh, I need to lock it in so it's okay. Yeah, that's not right. Okay, so sum of all of this. Okay, and I want to put dollar signs around that first one and tell it to keep going back all the way at the beginning. So now when I drag it down, there we go. That makes more sense. So what it's doing is it's going, so here it's saying go to the 1 and add all the way down, go to the 1 and add all the way down. And so the nice part is I can drag this, I can drag this, and it's already pre-programmed to do what it's supposed to do. And this guy I just need to pre-program. So this one is going to be 9 plus 1. And so now if I drag that down a couple days, I get new numbers. Drag that down, I get new numbers. Drag that down, I get new numbers. And now the cool part is, now that I've got them all programmed, I can just drag all 3 down and it will update the chart as it goes. Okay? That's kind of a neat little trick about Excel. Okay, now what I need to do next is I need to figure out the total value. Well, the total value, since these are pennies, is 0.01 times that, which isn't worth much. Right? But again, I can drag it down and it will calculate the amount of dollars that each one is worth. So now I've got this wonderful little chart that I've made that'll keep dragging down dollars. Okay, now let's actually go to your question. Question says total number, okay. How many days would elapse before she gets 1 trillion? Okay, so we need to clarify how many zeros are in 1 trillion. And it's that many zeros. So 1, 2, 3, 4. 4 sets of 3. So 1, 2, 3, 1, 2, 3, 4. Okay, so I want to know when that number, the size that big, shows up. I'm actually going to convert that. Yeah, let's make that in scientific notation. Alright, so when I get to e to the 12, then I know I've got my number. So then I'm just going to keep dragging this down and look and see when I get e to the 12. We're almost there. Okay, so notice I was looking for scientific notation to the 12th power, and I got that right around the 47th day. So on the 47th day going into the 48th day, that's when it crossed the trillion threshold. So 47 days on that, which I believe is the one of your questions you asked me. 47 days, okay. Next question, a certain element has a half-life of 3.5 billion years. You find a rock containing a mixture of the element and lead. You determine that 35% of the original element remains and the other 65% is decayed in the lead. How old is the rock? Alright, so we need our formula chart on half-life. So let me go pull that up. Okay, so here is our formula for half-life. It's this lovely guy right here. Exponential decay model. So I'm going to take a picture of that and throw that over into my Excel spreadsheet, and then we'll answer your question. Oh, give me a second. Oh no. Okay, so I got it to show up over in Excel, and so here's our formula, right? So I've got new equals the initial times 1/2 to the t over 3.5. That's what I'm trying to figure out, is the t, okay? So I'm saying if my initial amount was 100% and I now have 35% left, how long did it take before something like that happened? Okay. If you know exponent rules, you can use exponent rules to kind of play around with this. I'm going to go sort of a different route. Since we have Excel here, I'm just going to use it. And what I'm going to do is I'm going to just guess a number for t. And I'm going to say, let's start off with 3.5. It's not going to work, but I want to show you what happens when I program it this way. Okay. So I'm going to say take the initial times parentheses 1/2 caret, and then I'm going to take my t divided by 3.5 and hit enter. Okay, now what I've done is I've said when t is 3.5, I'm left with half of my material. I want to know when it's 35. So I'm going to come over here and I'm just going to play with this number. I'm going to try 4, see what happens. Okay, still not there yet, but it's getting closer and closer to 35. So I might try 5, and it's not enough. I'll try 6. Alright, 6 is too low. So I know it's somewhere between 5 and 6, and I'm going to play the high-low game and play around with it. So 5.5, oh, too low. 5.4. Too low still, 5.3, and there we go, there's my 35, so I got it to match. Okay, that actually will work for this test. You don't have to be that accurate, so you can play with numbers to get it to match. So coming over here, analysis of another rock shows it contains 55%, so I want it to say 55 out of the initial. How old is the rock? So I'll go to 3.5, and that's too, so I need to keep going lower. So we'll say 3, and I get 55.2. So if I go 2.9, I'm already, I've already gone past it. So 3 is the closest number that I can get, and again, that's fine. So that's one way to do it. If you know about exponent rules, I'll kind of show you a exponent rule method to do this. Okay, so here's that same equation, but this time I'm going to show you some exponent rules that will also do the same trick. Again, 35 and 100, and then I'm just going to copy and paste that. Oops, that's not what I meant to do. I meant to do that. Okay, so if I divide by 100, I get 0.35 equals that fraction again. And what I want to do is I want to take the ln of both sides. And again, if you don't know this method, then I wouldn't use this method. Now, taking the ln of both sides allows me to bring out that exponent there. So let me kind of do that. So this exponent that I have up top, I can bring it out front of the ln. Now it's actually, oops. So it's t over 3.5. So it actually isn't an exponent anymore, it's just a fraction. And then I can multiply both sides by 3.5. That equals t ln of 1/2. And then I can divide by ln of 1/2. So I take this thing, put that on the top of a fraction, and then I want to divide that by ln of 1/2, and that will equal t. And so if I go type that in a calculator, which I will pull up, all right, so 3.5 times the ln of 0.35 gives me a number, and I'm going to divide that by the ln of 0.5, and I get 5.3. Okay, so notice guess and check on Excel works just fine. There is a mathematical formula that you can use to actually generate this. So if you're familiar with exponent rules, you can go that route, and then you have to know how to type it in your calculator, or you can just use Excel, and that should work as well.